Hello, welcome back once again. In our today's video, we're going to prove that the following given limit is exactly equal to 1 all over 2. We have limit as n is approaching infinity of the square root of n plus root n minus root n. How exactly are we going to prove that this limit is exactly equal to 1 all over 2? Let's think about rationalization. We already know that the conjugate form of this expression here is root of n plus root n, then plus root of n. And therefore, we're going to multiply the numerator and the denominator by the conjugate form of this expression. So here we have our limit to be equal to the limit as n is approaching infinity, and doing what I just said now, this is square root of n plus root of n minus root of n, then divided by 1. 1 here is the denominator, and we're going to multiply the numerator by the conjugate and the denominator as well. So this will be root of n plus root of n, then plus root of n, which is the conjugate, then divided by root of n plus root of n, then plus root of n. Okay, now take a very good look at the numerator. Here we have difference of two squares. Let us take note of this. When we have a minus b multiplied by a plus b, this is simply a squared minus b squared. So we can see this is applicable here. We only have these different signs. Here we have negative and here we have positive. So make use of this. So our limit will be limit as n is approaching infinity. So right over there, that will be square root of n plus root of n squared, then minus root of n squared, then divided 1 times this is that, right? Okay, so this is what we have from here, and this is equal to limit as n is approaching infinity. So this square we cancel this root sign, square we cancel root sign, so we just have n plus root n minus n, then divided by square root of n plus root n plus, is that root n? Yes, that is root n. Okay, so from here, subtracting this will be 0, right? So we have this to be equal to limit as n is approaching infinity. So we have just root n up there, and we have over root of n plus root of n, then plus root of n. So what exactly do we do from here? Let's go ahead and divide the numerator and the denominator by root of n. So here, root of n divided by root of n, then all over here, square root of n plus root of n. We're going to divide this by root of n, and here plus root of n divided by root of n. So from here, we have limit as n is approaching infinity. So this exactly here is 1, then divided by, remember, when we have square root of a divided by square root of b, this is the same as square root of a divided by b. So here will be the square root of n plus root of n divided by n. Then we have plus 1. So from here, we have limit as n is approaching infinity. So from here, we have 1 divided by root of, splitting this denominator here, n divided by n is 1, then plus root of n over n is same as 1 over root of n, then plus 1. And from here, we can make our direct substitution. So this will be equal to 1 divided by root of 1 plus, now 1 over root n as n tends to infinity is 0, right? So we have 0 here, then plus 1, which is equal to 1 divided by square root of 1 plus 0. 1 plus 0 is 1, square root of 1 is 1, so we have 1 plus 1, which is exactly equal to 1 over 2. And here we have proven it, that the limit equals 1 all over 2. Thank you for watching. Please kindly subscribe to my channel Also like, comment and share. Bye bye.